Good day, learners! Today, we will learn about heat. Is a form of energy that transfers from one body to another. It is also termed as an energy in transit. Imagine a cup of hot coffee on a table. If you put some ice cubes on the hot coffee, what do you think will happen to the hot coffee? What will happen to the ice cubes? The coffee is hot, while the ice cubes are cold. When mixed, the coffee cools down and the ice cubes warm up and melt. Heat flows from the hot coffee to the ice cubes. Heat is measured using a calorimeter in joules or calories. 1 calorie is equal to 4.184 joule. Heat is different from temperature. It is the measurement of how hot or cold something is. Heat energy causes a temperature to increase or decrease. Temperature is measured using a thermometer in Kelvin, Celsius, and Fahrenheit. Kelvin is the standard unit for temperature. Now, what do you think will happen if you put a scoop of ice cream into a warm bowl? What will be the direction of the heat flow? Heat flows from an object with higher temperature to an object with lower temperature. Since the bowl is warmer than the ice cream, heat flows from the bowl to the ice cream. Now, how does heat flow on solids? Heat can flow through a solid. This movement is called conduction. Heat is conducted from the hot end of the solid to its cooler end. The term conductor is used for objects that allow heat to flow easily through them. Metals such as copper, gold, and aluminum are examples of conductors. On the other hand, insulators are objects that do not allow heat to flow easily through them. Fabric, wood, and foam are examples of insulators. Now, let's talk about thermal energy. It is the energy contained in an object due to the motion of the particles in a system. For example, if we have two beakers with different amount of water, beaker A has more water than beaker B, it will take a longer time to bring the water in beaker A to a boil. If the water in both beakers are at boiling point 100 degrees Celsius, the water in beaker B will cool down quicker than the water in beaker A because beaker A has more thermal energy. Now, we also have the term thermal expansion, the tendency of matter to change in volume in response to the temperature change. With higher temperature, thermal expansion happens. Here, the liquid rises up as the temperature rises, and that is because of thermal expansion. Another one is what we call the heat capacity, the amount of heat needed by a material to increase its temperature by a degree. Every material has its specific heat capacity, the amount of heat required to increase the temperature of a gram of a given material by 1 Celsius degree. Say for example, here in the table, water has the highest specific heat capacity with 4.18 because it requires more heat to increase its temperature by a degree, while lead has the lowest specific heat capacity with 0.13 because it just requires less heat to increase its temperature by 1 degree. So that's it. I hope you learned something today. Thank you so much for watching.